Alright, so in this video we are going to publish our first smart contract. So in order to deploy a smart contract or publish a smart contract to the blockchain, then we're going to go ahead and need to download Mist. Okay, so Mist is basically an Ethereum browser that is provided by the Ethereum Foundation, who's the people that are writing Ethereum at this point in time. And so in order to download this application, we're going to go ahead and go to this website, github.com/ethereum/mist/releases. Now you'll notice that this isn't version 1, this is version 0.9, meaning that this actually is not finished yet. In the future it will be a little bit easier to use, hopefully, once it's finished. But at this point it is, not finished yet. So this is still a developer kind of thing. So if this is too advanced for you, maybe you can just watch it and not actually download it. You could just kind of see the process without going for it. But if you want to go for it, then you would scroll down to here and download, if you're using a Mac, this one right here, which is Mist. Okay, there's actually two applications that you could download here. There's the Ethereum wallet, or there's Mist. The thing is that Mist includes the Ethereum wallet. And so if you just want to get two in one, then go ahead and get Mist. So we'll go ahead and download that. And then once you have it downloaded, you would unpack it and do all that sort of thing. And then it would be this one right here. You'd click it, you'd get a window, something like this, once it pops up. Okay, something like this, where it's going to update it. Now, if this is your first time opening, it's going to take a long time to sync everything. Now, we're actually just going to use the test net, and so it'll probably ask you when you first use it, do you want to use the test net or do you want to use the main net? And if you choose the test net, it'll actually load a lot faster, okay, because there's only about 700,000 blocks, whereas the main net has, I think it's like 4 or 5 million blocks. So make sure you're on the test net. And especially since we're just going to do these contracts that have no meaning, it's important that, well, not that they don't have meaning, but that we're not going to actually use them for anything. Okay, we're just doing it as a test. So it's important that you do it on the test network. So what you can also do to make sure you're on the test network is you go up to develop, and then you go to network, and then you go to test network. Okay, and then once you're on the test network, you need to get some Ether. There's a website here called, let's see what it's called. It's I think it's called Faucet. Yeah, Rinkeby Faucet. So just Google that, and then here we go. It's faucet.that, and then what you have to do is create a GitHub gist. So the way this works is it wants to make sure that you have a GitHub address or a GitHub account. So you'd go and you'd sign in, and then you would let's see here. I don't want to have to sign in. Okay, but anyways, you'd go through and you would sign in and then create a gist with this, and then you'd paste it and they'd send you Ether, okay, for free. So I'll link a video that explains how to do that. Okay, but then you have Ether in your account and you can now participate within the test network. So here's some accounts that I've created. When you want to create an account, you just say add account, and then you say create new account, and then it's going to ask you to enter a password. So since this is the test net, you could just use ABC123. If it was the main network where this stuff actually has value, then you would want to type in as strong as a password as possible. So that you can be sure that it's protected. Okay, and you'd want to write down that password and keep it secure where you're not going to lose it, because this is basically like, well, it's not basically, it is real money. And so if you have Ether on there and you lose it, then it's just like throwing away money. So you want to be very careful with your password. Okay, so then you type in a password and you'd press OK, and then it would ask you to repeat it. And once you press done, then you have a new account here that shows up. So I've already created 6 accounts, and I've transferred some Ether, this is just test Ether, between each of these accounts so that we can create a contract that involves all of these accounts. Okay, now if you want to send, you just go to send, you choose which account you want to use, you type in who you want to send it to, and then you would type in the amount you want to send and you press send. Okay, so that's what you can do right here. And then over here we have contracts, and here's all the old contracts that I've done. Okay, well we're actually going to create a new one. So if we want to deploy a new contract, then we click here, and we say which account we want to deploy it from. And if we want to load it with money from the beginning, we can type in Ether there, assuming our contract allows us, which we'll talk about later. And then right here, we would go ahead and write in our Solidity code. And then we would choose the fee that we want to pay to the miners. If you choose a small fee, that it's going to take a long time to get picked up by the network. It says a few minutes, but if you want to pay the miners a bit more, then they'll do it really fast. And you're probably not going to, actually you're for sure not going to use all of this Ether. There's just going to be a small portion of this Ether that is paid to the miners. Okay, but this is, it says right here, the most amount of money that might be used to process this transaction. So the more that you apply, then the faster it'll go, and the less you apply, the slower it will go. Because the miners obviously want to do the ones that are offering more money. Okay, so then we're going to say deploy. And then that would then take this contract, okay, but we actually have to, put stuff in here. Let's see, why didn't that work? Oh, okay, so yeah, so then I would type stuff in here, I'd select the contract, which in this case is just the blank one, my contract, and then I'd press deploy. Okay, and then it would allow us to submit this to the network once I type in my password. All right, so what we're going to do now is actually write a contract, and then we'll paste it in here, and then we'll deploy it to the network. So I could, if I wanted to, just go ahead and type in all the stuff here that I want to type in and do it through here. But as soon as I press deploy, then it's going to erase this field, and then I'm going to have to I'm going to lose basically what I just wrote. So what I'm going to do instead is use a different IDE is what it's called, an integrated development environment, to write this stuff. And so what we're going to do is go here, and we're going to go to the Solidity Documentation. This is solidity.readthedocs.io. Okay, I'll paste this URL in the comments below. And they recommend that you just use Remix. Okay, they actually have a whole list of different plugins for different IDEs that already exist, like Visual Studio, which is Microsoft's IDE, or you can just use all these ones that maybe you're familiar with. But the easiest one is just this Remix one, and what it's going to do is it's just going to open up a web page that actually has an IDE built into it. Okay, so here it is. So this is something that I was already working on earlier, and it just showed it up here. Okay, if you didn't have something you're already working on, then it would just pull up a sample ballot. Let's try this again. Okay, so here it has just the default thing, which is a ballot contract for voting. Okay, and so this one is too complicated for us. We're just going to write something simple. So I'm just going to erase all this once it loads here. And by the way, you're going to have to use Google Chrome in order for this browser to work. I tried to use Safari and it wasn't working. Maybe in the future it will work, but so far we have to use Chrome. Okay, so yeah, we're just going to type in our contract here, and then we can just copy it, and then go back to Mist, and then paste it in. Okay, and then we'll be able to deploy it. So I'm going to take a quick break. My computer the fan is going, it's all hot. So I'm going to take a quick break, and then I'm going to come back, and we're going to start writing that contract. Alright, so here we go, I'm back. Sorry, whenever I use a screen capture software that I use, my computer always starts overheating, so I have to limit it to a certain amount of time. Alright, so anyways, here I am, I'm back, and what we're going to do is write a contract here, and then we're going to publish it. So in the previous video when I was on the whiteboard, I talked about how we're going to make a payroll contract. and I'm just going to call it split it. Okay, so it's going to be called split it, and then we also have to have the constructor function in here. And by the way, you're saying, Kevin, how do you know how to do all this stuff? Well, what I did is I read the documents right here. So this is solidity.readthedocs.io. Again, it's in the comments below, and you could read through here where it talks about what all this stuff is about. Okay, but this isn't supposed to be like a hardcore programming tutorial. Instead, I'm just going to go pretty quick because I just want to demonstrate kind of an overview of what it's like. Okay, so first we need to have a constructor function, this is what's going to be called when the contract is first created. Okay, so it's going to be the same name as the contract name. And the code that's in here is going to execute when this contract is created. I think I already said that. Okay, anyways. So then we also have the second function that we also want to include, which is the fallback function. So the fallback function is whenever somebody sends Ether to the address of your contract. Okay, so if they don't attach, they're not calling a function, they're not doing anything, they're just saying, here's some Ether, well then this code is going to be executed. Okay, and so we want to have the fallback function in there. And then the third function that we'll have is the withdraw function. So the way that this contract is going to work is I'm just going to load it up, I'm going to pay in money to it, and then when my employees are ready to collect their paycheck, then they are going to go to the address and they're going to call this function. Okay, and it's going to pay them their fraction of whatever money is sitting in this account. Okay, so this is the withdraw function. So these are the three functions. That's all I'm going to need in this account. And of course, we're going to fill this in a little bit. But let's go ahead and just, for fun, I want to show you something. I'm going to try and deploy this. So I'm going to paste this in here. And I'm going to say which contract I want to do split it. I could have multiple contracts, but in this case, I'm just doing one. Okay, and then let's say that I just wanted to deploy this with money that then I wanted my employees to then withdraw money from. Okay, well, here's the thing. If I tried to attach Ether to this transaction in this current syntax right here, then it's not going to accept it. So you'll see right here it says, it seems this transaction will fail. Okay, now why will this transaction fail? Okay, well the reason is because the constructor function does not have the payable keyword. Okay, so if I have the payable keyword, and then I also have this Ether attached, and then I press deploy, then it will say everything's fine. Okay, and it will go through. So the reason this is because by default, contracts will not accept money that you try and send them to. And the reason being is that if you don't have a good withdraw function, or maybe somebody just left out this function altogether, okay, well then there's not going to be any way to get the money out of the contract. Because remember, contracts do not have private keys. There is no administrator that's in charge. All of the code that's in here is what dictates how the money is withdrawn. And so if you don't have a withdrawal function, then there's simply not going to be any way to get that money back out. And so by default, they leave out this payable keyword so that the contract will not accept Ether going into it. So if you want your contract to be able to accept money, then you have to include this payable keyword, not just on the constructor function, but on any function that you want to be able to accept money. Okay, so the withdraw function down here that we're going to have, like this, well in this case, we don't actually want to accept Ether. The people are just going to call this, and it's not going to make sense for them to, deposit Ether when they're calling this function. And you'll see how this all works in a little bit. So in this case, we're going to leave it off. But if somebody just tries to send Ether to this account, well, we want to accept it. And so we're going to include the payable keyword on this function. Okay, so there we go. So now I'm going to go back to here, and I'm going to type in payable here and payable here. Okay, and then we have our withdraw function here. So the way this is going to work is that there are going to be 5 addresses that I program in here. And so I'm going to call them my employees. Okay, and I'm going to put in, this is an array of addresses. If you're not familiar with programming and you don't know what an array is, basically it's just a, what do you even call that? It's like a storage thing where you can make a list of stuff. But I'm assuming you are already kind of familiar with programming. If you're not, then you're just watching this just to see what it's like, and you could probably fast forward through all this just to see what it's like when I deploy something. But if you're already a programmer, then you understand what an array is. Okay, so I'm going to go ahead and copy this on my iPad here, and it'll paste in. Okay, so then we're going to paste this in from my iPad, and here we go. So now we have all of these different addresses. Okay, and so these are the addresses of the employees that are going to be able to withdraw their paycheck. So if I go back to my Mist browser, and then I go back to the wallets, you'll see that these are actually, if you look at these addresses, they match each of these people. Okay, so employee 1, employee 3, and employee 2, and stuff like that, right? So these are the addresses of these 5 accounts, and so we'll be able to test it later. Okay, so now I'm going to go back here, and so now we have these 5 accounts, and so we're almost ready to go. But we need to figure out some way of keeping track of all the money that's paid into this so that we can divide it evenly between these 5 accounts. And so the way that I've figured out how to do this is by keeping a what do you call this? A counter of all the ether that's been input into this account. So I'm going to call it total received, and I'm going to start it at 0. Now, what I'm going to do here is when the payable function is called or the fallback function is called, we're going to update this total received, because that's the only 2 ways ether can come into this account, because they both have the payable function. So I'm actually, since I'm going to use it in 2 places, I'm going to write a brand new function, and I'm going to call it update total received. Okay, and since I don't want the outside world to be able to see this, I'm just going to call it internal. So what this is going to do is it's going to say total received is equal to, actually it's going to be plus equals, which is just going to increment whatever it is by whatever I type in right here. And so I'm going to type in message dot, actually not sender, message dot value. Okay, so total received increment by message dot value. And the message dot value is whatever is in, put a semicolon. The message dot value is whatever is in this thing right here. Okay, if it's 0, then it'll be 0. But if it's something, it's going to be whatever it is that's in there. Or in the case of if I'm just going to type in the contract's address here and send ether, then that will be the message dot value. And it's actually going to be stored as an integer, and it's going to be in way, which is the smallest possible, I think it's the smallest possible, or it's one of the smallest, yeah, I'm pretty sure it's the smallest possible division of an ether is a way. And so it'll be like a really long thing like that, okay? So anyways, total received is equal to 0, and then we want to call this update total received when somebody pays into the contract or when somebody creates the contract, assuming they have also included some ether in the contract creation thing. Okay, so here we go. So now the total received is there, but now we have to figure out a way to withdraw it equally between all of these people. So first what we want to do is check to make sure that they're actually one of these people. And so what we can do is create what's called a function modifier, and I'm going to call it canWithdraw. Actually, you don't use that. You just go like that. Oh, no, you do. Sorry. Reading from my notes here as I write this. Okay, so it's called a modifier, and we say canWithdraw. Okay, and so what I can do now is basically return a yes or no, or what we call a Boolean, right here, and then what it will do is it'll make sure that this condition is met when I call this function. Okay, so let's write this out and it'll become a little bit more clear. So what I'm going to do is check to see if the address that is the message.sender is actually within one of these 5 addresses that I have listed as my employees. In other words, I'm checking to see if this is an employee. So I'm going to create a variable here, contains equals false, and then I'm going to have a little loop that goes through here. So I'm going to say for UI int equals 0. And I'm going to say while I is less than employees dot length, then I'm going to say I plus plus. Okay, and so this is just going to loop through here, and if this condition is met, which is employees at I is equal to message.sender, then I'm going to say contains equals true. Okay, and then once this is over, I'm going to say require contains, which if it actually is one of these employees is going to be true, and then I'm going to do this thing. Okay, and this is just the format of a modifier function. Okay, so why is it giving me an error here? For I, oh, I forgot to do the name of this. Okay, so this is going to be, we'll just say I equals 0. Okay, so now it's going to go through here and it's going to go. Now you might say, well, why don't you say break here? Okay, and so that, you know, it just is a little bit more efficient. Well, the reason is because if you're this first employee, then you're not going to have to pay so much gas in order for this to go through. But if you're the last employee, then you're going to have to pay a little bit more because this loop is going to run 5 times, or I guess 4 times before it, 5 times before it calls you, right? And so I actually am going to let it go through every single time so that every employee has to pay the same gas price. Okay, so that's just my way of doing it. Some people may put break here so that it doesn't waste gas, but I think that it's right that every employee has to pay the same amount to withdraw their money. Okay, and then, so now this function is only going to be called if this condition is met. Okay, and so now I can just copy this and paste it right here as the function modifier. Okay, and so now I know that whoever is going to call this function, the withdraw function, is an employee and they are able to withdraw money. So now I'm going to type in the rest here. So the first thing I have to calculate is the amount allocated for this person to withdraw. And so I'm going to say total received, which is this thing that I'm keeping track of right here, divided by employees dot length. Okay, so if there's 5 employees, which there is, then it's going to divide the total received by 5. Okay, in order to see how much is allocated to that person. Now, we want to make sure that they don't withdraw their money twice, right? So we need to have some sort of way of keeping track of how much money they've already withdrawn. And so I'm actually going to create another global variable up here, and it's going to be what's called a mapping. Okay, and a mapping is kind of like a dictionary, but it's a little bit different. You can read the docs as far as how this is treated. but for now you could just say it's like a dictionary. Okay, and it's going to be address, so the key is going to be an address, and then you're going to it's going to return a integer. Okay, and so then I'm going to say withdrawn amounts. Okay, so now we have a dictionary here where I could store this information, and you'll see how I update this in the next line, I guess the next 2 lines. Okay, so, but right now I just want to check if they've already withdrawn anything. So I'm going to say amount withdrawn is equal to withdrawn amounts, and then it's like a dictionary, so I'm going to have these brackets here, and I'm going to say message.sender, which is the address of whoever is calling this function. Okay, so it's going to put the address in, and it's going to return either 0 if they haven't withdrawn anything, or it's going to return however much they have withdrawn. Okay, and then, so now that we have that, we can determine how much we want to give them, which we're just going to call amount, and that's just going to be amount allocated minus amount withdrawn. Okay, so that's what we want to give them, and then we also have to update how much it is that they have withdrawn. And so what I'm going to do is say withdrawn amount for message.sender is equal to amount withdrawn plus amount. Okay, so now this is updated for the next time they call withdraw. And then I'm going to say if amount is greater than 0, then I'm going to send them the amount. Okay, so this is transfer amount. Okay, so if amount is greater than 0, in other words, if there's money allocated for them that is greater than the amount that they've already withdrawn, then I'm going to go ahead and send them that amount. And if not, we're just not going to do anything. Okay, so that's it. That's our whole contract. And so the way this works is that people can pay in money to this account. Maybe it's even your customers are just paid into this account. And then as they pay in, the total received is going to increase. Okay, and so it increases right here when I say update total received, which is called either when the contract is created or it's called when people pay in money. And then once my employees are ready to receive their money, then they are going to call this withdraw function, which I'll demonstrate how that works in a second, and it's going to check if they are an employee, okay, if they can withdraw, and if this is true, then this function is going to be called, and it's going to calculate how much they've already withdrawn, how much is allocated to them, and then it's going to determine the amount we're going to pay them, and it's going to update however much they've already withdrawn for the next time they call this, and then if it is anything to give them, then we're going to go ahead and send it back to them. Okay, so now this is all finished, and what I'm going to do is copy and paste this. We're going to go back to Mist, and we're going to go to contracts, and we're going to say deploy new contract. I'm going to do it from my main account, and remember, we can now send in Ether, so let's send in like 5 Ether. So I'm going to send in 5 Ether to this. I'm going to paste in the code. Okay, it has these addresses in here, all this stuff, it's all good. So I'm going to say pick contract, it's going to be the split it contract, and then I'm going to go ahead and press deploy. It's going to ask me for my password, then I'm going to go ahead and paste in my password, and I'm going to go ahead and press send transaction. Right, now if we scroll down, you'll see that it's right here and it's loading. So right now we have 0 of 12 confirmations. And so what's happening is it's waiting for the next block to go through, and then it'll be applied in the next block, or maybe the next 2 blocks, we'll see. Okay, and so we're just waiting for this to go through. And then once it goes through, we'll go back to contracts, and we'll be able to find it here. Okay, in contracts. All right, so there it is. And so you can see it's that dark green one. So I'm going to go back to contracts, and here it is. It's the top one. It's the dark green one. And here we go. So it split it, and it has a name on it, and it should have a balance. Okay, there it is. Phew, I was going to say we lost our ether, but no. Now it's updated, and it has that 5 ether that I sent into it. Okay, now what this means is that if I call this function, withdraw, from one of these employees who have been listed in there, then they should each get 1 ether. Okay, so let's go ahead and test that. So I'm going to scroll down here, and I'm going to go to withdraw, which I already have selected, and I'm just going to say employee 2. Okay, now employee 2 right now has 0.44 ether in their account. And so once I'm done with this, they should have 1.44. Okay, so I'm going to type in my password, and I'm going to press send transaction. Okay, so transaction sent. Again, if we go back to wallets and we scroll down, it's going to be going through here. We have to wait to the next block. Okay, but what we should see is that I think it was employee 2 is now going to go up to 1.44 ether once this is confirmed. So we'll go ahead and wait for this to go through. Okay, there we go. And then there it is. Employee 2 moved up to the top here, and because it's sorted by the amount, and they have 1.44 ether. Okay, so now I could go through here and test this by calling it with all the employees, but you get the point, okay? Now if I add more ether into this, then employee 2 should be able to withdraw again. Okay, and so we can also test that, but I've already tested it and I know it works, okay? So anyways, that is our awesome smart contract, okay? It is called Split It, and you have all the addresses in here of the employees, and then you pay in money, and then you could withdraw it equally between these different people. Okay, so pretty cool. Gives you a sense of how this all works, and I hope that helps. Okay, so thanks for watching, and I will see you some other time.